There is a failure inside your network right now that your monitoring system cannot see. Not because the alert didn't fire, because the failure was never designed to look like a failure. It looks like Tuesday. It looks like normal traffic, normal load, normal everything. Right up until it isn't. This is the part nobody tells you about AI-powered monitoring. It doesn't fail loud, it fails invisible. A system can be actively breaking down for weeks, slowly, quietly, and your dashboard will stay green the entire time. Because green was never a measurement of health, it was a measurement of familiarity. I call this the AI baseline trap. The mechanism that quietly turns real degradation into invisible failure. And once you see how it works, you'll never trust a green dashboard the same way again. In the next 12 minutes, I will show you exactly how failure hides in plain sight inside modern monitoring systems, why even sophisticated AI can see it, and what it actually takes to drag it back into view before it becomes an outage. Let's get into it. Here is what's happening across enterprise IT right now. AI-driven monitoring and network automation have gone from nice to have to standard infrastructure. Abnormality detection engines, predictive maintenance tools, self-healing network platforms. They are baked into everything, from Cisco's AI-driven operation tools to custom ML pipelines built in-house by SRE teams. And the pressure driving this is real. Networks have gotten too big, too fast, and too complex for humans to watch manually. A mid-sized enterprise network today generates more telemetry in an hour than a human team could review in a week. So the industry did the logical thing. It handed the watching over to machines. This affects almost everyone touching infrastructure today. Network engineers, SREs, security operation teams, even engineer leadership making the call on tooling budgets. But here is what almost nobody accounts for. Handling the watching over to machines didn't just change who looks. It changed what counts as visible in the first place. The dashboard says green, so nobody double checks. The system didn't flag it, so it must be fine. That shift is exactly why invisible failure gets manufactured, not hidden by accident, built in by design as a side effect of how this system learns. If you manage, build, or depend on monitored infrastructure, this applies to you directly. Let's break down why. So, what is AI actually doing inside your monitoring stack? And why does it lose track of things a person wouldn't? First, what AI is doing well. It is a pattern matching at a scale no human can touch. It indigests thousands of metrics: latency, packet loss, CPU load, error rates, and builds a statistical model of what typical looks like. When something deviates far enough from that model, it raises a flag. That part works, and it works fast. Second, where humans still dominate. Context. A machine sees a spike in traffic. A human remembers that's the last day of the fiscal quarter, and finance is running bad reports. A machine sees latency creep up by 3%. A human knows that 3% on this specific link historically precedes a hardware failure. The model does not know what it does not know. It should ask, which means it can't tell the difference between a failure that is hidden and one that is simply hasn't happened yet. Third, the hybrid model. The system that actually works well aren't AI only or human only. They are AI-assisted judgment. The AI does the scanning, the human does the interpreting, and the interpreting is where invisible failure either gets caught or gets missed for good. That interpretation gap is exactly where the baseline trap lives. Let's go inside it. Invisible failure doesn't hide in one place, it hides in three. And once you know where to look, you start spotting it everywhere. 1. It hides inside the data itself. An anomaly detection model learns normal from past data. If a system has been degrading slowly for months, a memory leak, a slowly failing fan, a router quietly dropping more packets each week, the model doesn't see decline. It sees a new normal. The failure isn't missing from the data. It's inside the data, wearing the data's own colors. Explanation. The model isn't comparing you to LD, it's comparing you to yesterday. Impact. A real failure condition can exist for weeks, fully absorbed into the baseline. Invisible, not because no one is watching, but because the system watching has learned to call it normal. So here's the question worth sitting with. If your monetary system only ever compares today to yesterday, who is checking whether yesterday was already broken? 2. It hides inside the fix. Modern network automation, the kind being pushed hard across the industry right now, is genuinely impressive. Predictive routing reroutes traffic before congestion becomes visible to users. Self-healing systems quietly restarting failing services. And this is where invisible failure gets even harder to catch, because something is actually broken, and the system's own defenses are working overtime to make sure nobody ever finds out. Explanation. These tools are designed to hide symptoms in order to protect user experience. Impact. The underlying root cause never gets fixed because nothing downstream ever looks broken. You get a network that is excellent at making failure invisible, not at resolving it. 3. It hides inside the org chart. This shifts the scale that actually matters. It used to be, can you fix an outage fast? Now, it's, can you find the failure? Nobody's system is built to show you. Explanation. The valuable engineer isn't the one staring at dashboard, waiting for red. It is the one who assumes something is already invisible and goes looking for it anyway. Impact. Teams that don't build that instinct in keep getting blindsided by failures their tools technically saw, processed, and quietly decided not to mention. 3 different places, same result. The failure was never gone. It was just never designed to be seen. Quick pause. If you are realizing your own monitoring stack might be doing exactly this, it genuinely helps this reach more engineers dealing with the exact same blind spot. Okay, back to it. So does this mean AI monitoring is a bad bet? No, it means AI monitoring left alone will always drift towards invisibility, because that is what optimizing for, no alerts, naturally produces. Here is why a human still has to sit above the system. AI can tell you what's changed. It struggles to tell you why it matters. And it has zero instinct for going looking for a failure that isn't currently causing a metric to move. A 5% increase in error rate on a legacy payment gateway is not the same risk as a 5% increase on an internal login service, but a model trained purely on deviation treats them almost identical unless it's being very deliberately taught otherwise. There's also an ethical and security dimension. Automated systems that self-heal or auto-remediate are making judgment calls with real consequences. Rerouting sensitive traffic, restarting services mid-transaction, suppressing alerts to reduce noise. Every one of those actions makes something less visible. Someone has to own accountability for that trade-off, not the algorithm, a person. That is why I think about humans in this role, not as a backup plan, but as a system governance. The ones whose entire job is to keep dragging invisible failure back into view before it becomes urgent. The AI is the sensory network. The human is the one who refuses to accept no alert as proof of no problem. That's not a downgrade for human engineers. That's a power shift. You are not the one watching the dashboard anymore. You are the one deciding what the dashboard is even allowed to hide. So, where does this go from here? We are heading towards networks that are increasingly autonomous by default, self-optimizing, self-healing, self-rerouting, with less manual configuration involved day to day. That part is coming, whether teams are ready or not, which means the system getting better at hiding failure are the same ones about to get more control. But the winning model isn't full autonomy, it's structured collaboration. AI handling scale and speed, humans handling context and consequence, with clear checkpoints, specifically designed to force invisible things back into view before automated decision touch anything critical. And that's already creating roles that didn't exist 5 years ago. Roles whose entire function is hunting for what the system isn't showing you. AI network supervisors, whose job is specifically to audit what the automation is deciding and what is quietly deciding not to surface. Automation architects, who design the guardrails that keep failure from disappearing into the fix. Baseline auditors, whose entire function is to periodically challenge the assumption that normal C equals LD. The teams building these roles in now before invisible failure becomes a very visible outage are the ones who will be ahead when that shift fully lands. Here is the core insight to take with you. AI monitoring doesn't fail because it's weak. It fails because it was never built to go looking for what it can't already see. And if nobody on your team is doing that looking either, you don't have a monitoring system. You have a very expensive way of confirming failure after it's already stopped being invisible and started being an outage. The dashboard being green was never proof you were safe. It was just proof the failure hadn't finished hiding yet. If this changed how you think about your own monitoring stack, subscribe. This channel breaks down invisible blind spots like this in modern IT systems every week. Next, watch the video on my screen now where I break down the 3 specific metrics most AI systems are trained to ignore. and drop a comment. What's the most invisible failure your team ever caught too late? I want to hear it.